All right, number 10, we have two parts. We're going to rewrite the expression without logs, and then we're going to solve it. So we start out with log base 9 of x plus 4 plus log base 9 of x plus 1 equals 1. All right, so property of logs, if we're adding two logs with the same base, we can write it as multiplication. So we'll first rewrite this as log base 9 of x plus 4 times x plus 1 equals 1. So we have just one log expression now. We're going to write this in exponential form. So 9 will become my base to the first power equals this. So we'll have x plus 4 times x plus 1 equals 9 to the first power, or just 9. So this is part 1. Okay, we just want to rewrite it without exponents, and we'll just write 9. Okay, 9 to the first power is just 9. Anything with an exponent of 1 is itself. So we'll write x plus 4 and then x plus 1 equals just 9. So that's part 1. Write it without exponents. All right, now part 2, we actually are going to solve. So we're going to FOIL this side out. That will give us x squared and then plus 1x plus 4x, so plus 5x. And then plus 4 equals 9. Okay, then we want to set one side equal to 0 because this is quadratic. So we'll subtract 9 from both sides. That will give us x squared plus 5x. This will become a minus 5 now, equals 0. Factors of 5 are just 1 and 5. That's prime number. Can we subtract and get 5? No, we can't. So we cannot factor. We have to do quadratic formula. So we're going to do negative b, negative 5, plus or minus the square root of b squared. So 5 squared is 25. Minus 4 times a, which is 1, times c, which is negative 5. All of this is divided by 2a, or 2 times 1, which is just 2. Okay, we're going to simplify under here. A negative times a negative is a positive. This will give us 20. Positive 20 plus 25 will give us 45. So we have negative 5 plus or minus square root of 45, all divided by 2. We want to reduce the radical if possible. Always try it, no matter if you think it does or not, always try it to break it down to primes. Square root of 45. That will break us to 9 times 5, and 9 is 3 and 3. 3 times 3. Okay. So we get a pair of 3s, we get to pull out, and we have 5 left. So this will simplify to be negative 5 plus or minus 3 on the outside, and then square root of 5 divided by 2. Now you have two answers. Negative 5 plus something. Okay. If we just thought about square root of 45, it's close to 49, which is a perfect square. That's 7 times 7. The next smallest would be 6 times 6 is 36. This number should be between, because if you think 6 squared and 7 squared, 6 squared is 36 and 7 squared is 49. All right, so 45 is in between these, so it should be 6 point something, okay, and it should be closer to 7. So anyway, we're just using estimation. This number here is 6 point something, which is bigger than 5. So if I do 5 take away 6, 6 take away 5, because that's negative, this will leave me with a positive number. And then I would divide it by 2. It would still be positive. So the positive answer should be good. -5 plus 3 square root of 5 over 2. This answer should be good. However, if you were to subtract, so you got 5 take away 6, that would be negative. Divide by 2, it would still be negative. And we cannot use negative numbers when we evaluate log. Actually, yeah, that would be bigger than -2, because that would be almost 12 divided by 2. So that one, it wouldn't work here. So the second answer, when I do minus, won't work. So this will be my only true answer. Make sure you reduce it. If you put 45, it probably won't work. But let's see, just in case you get something that you're not certain will reduce. Do a division bar, -5. Let's just say plus the square root of 45 over 2. So that's this non-reduced answer. It just says to find domain, remember, finally check. Okay, it doesn't even tell us that your answer is in the correct form, so just be very careful here. This should be the right thing. Normally it would say, although your answer is equal to the correct answer, is not in the correct form. It didn't even tell us that. So just add a 3 square root of 5. So this is the reduced form. Okay, and that's it. So make sure you reduce it all the way down.